All right, guys, 6.5 is a relatively short one. It's just introducing the reciprocal functions, the graphs of the reciprocal functions of the primary ratios, sine, cos, and tan. So we know that cosecant is the reciprocal of 1 over sine. We know that secant is the reciprocal of 1 over cos. And we know cotangent is the reciprocal of 1 over tan. That's pretty straightforward. And we know what the graphs of sine, cos, and tan look like. So we're going to apply what we know about reciprocals from last chapter to the graphs of sine, cos, and tan in order to determine what the graphs of the reciprocals look like. So remember from reciprocals from 6.1 that a reciprocal has a vertical asymptote at each x-intercept or 0 of the primary function. So I'm going to do that first on this one. So down below we have the sine graph, and I am interested in graphing the cosecant graph. So the sine graph has x-intercepts here, 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 and here. If we're trying to graph its reciprocal, well, its reciprocal should have vertical asymptotes at those x-intercepts. What else does it say? It says they have the same positive or negative intervals, but intervals of increase or decrease are reversed. So that means sine is positive here, so our graph's going to be positive here. Sine's negative here, sine's positive here. So our graph is going to be in the same parts of those squiggly sections of the graph. It's not going to be in these four areas. Also, it says they work opposite. So if this graph is increasing to this point, well, our reciprocal, do a different color, should be decreasing to that point. Now it also says that local minimums of the primary function become maximums and vice versa. So this spot, the red dot that I've drawn, is a maximum for the sine graph. So it needs to be a minimum for our reciprocal, which means it's going to continue back up. Same goes here. Our graph is decreasing to here, so our graph must be increasing to that spot, and it will come down. Now they'll share the same spot always, that spot here. Why? Because it's at -1, and the reciprocal of -1 is also -1. That's why our reciprocal goes there. Same here, the sine graph has a y value of 1, so the reciprocal of 1 is +1, so it'll be at the same spot. And that'll continue across our graph here. Whoops. And down here. And so characteristics that we recognize here, well, they intersect at 1 and -1 all the way across. Maximums are the minimums of the reciprocals and vice versa. And anywhere that there was an x-intercept for our original graph, all the green dots are vertical asymptotes for the reciprocal. So that's how we can graph cosecant theta. We're going to do the same thing for cos. And you're going to see that since cos graph is pretty much the same as a sine graph, just transformed a little bit, or translated, I guess I should say, the secant graph is going to be very similar as well. So what we have here is the cos graph. I know that because it starts up at the top here. But I'm going to label all of the x-intercepts that we have, and I'm going to draw vertical asymptotes at those. All the way across. And you see a lot that's familiar here. This maximum at 1 would be the minimum. So you might say, where's the other half of this graph? Well, just like the sine graph would continue down, the reciprocal would continue up. It'll come up, touch here. Should put arrows. Continue up. Save that, share that spot at 1, continue up. And that's the graph of the reciprocal of cos. So it's very similar for sine and cos, the reciprocals. And lastly, tangent. And we want to graph cotangent. So same idea, I'm going to put where the x-intercepts are and draw my vertical asymptotes. so. Now, let's go with our graph. I know that the original graph is up here and then it's down here. So they have to be in the same section of the graph. So how's that going to work out? Also, we know that the original graph has a vertical asymptote here. So we know that if there's a vertical asymptote, the reciprocal will have an x-intercept. So our graph should pass through here. This graph here is increasing. Reciprocals do the opposite, so it's got to decrease to this spot. Over here, our graph was increasing, so our graph should be decreasing throughout. And that's what we have. And there's going to be multiple of these. Everywhere that there's an x-intercept was a vertical asymptote of its reciprocal. Like so. So that's the graph of cotangent. There we go. So the idea for this section is just so that you know that they exist, what they look like. We don't do a whole lot with it for now, but there's a couple of questions that you can answer in your textbook down at the bottom at 353, 1 to 3. And remember, you can get your textbook online as they've provided it for free. Details are on the website. So if you have any questions, let me know. We'll talk soon.